Okay, this is the second of the 3 units that are going to be on your quiz D. So this one is only 1 page long. You should be able to find that in your notes that I emailed to you. When you add and subtract radical expressions, it's very much similar to adding and subtracting terms of polynomials, because it's going to be, you have to identify what the like terms are. So to add and subtract radical expressions, first of all, you need to simplify each radical if they can be simplified. And then you're just going to combine the coefficients on the radicals. So you cannot add the radicals to each other. You're not going to add the radicals, you're going to add the coefficients, or the number in front of them. And the radical expressions, that means the number under the radical sign has to be exactly the same before you can combine them. So it's similar in a way if we have x squared plus 5x plus 2 plus 3x squared plus 6x minus 5. It would be similar to something like this. The things that we use to identify by is the exponents. So here I have x squares and here I have x squares. So these are considered like terms because they both have the variable expression x squared on it. So this would be 1. And we don't usually write it in front of the x, but we're going to find out that when we work with radicals, it might be easier to go ahead and put that 1 on the front. So here we would combine the x squares, so we'd get 4x squares. Then over here we have some x's that are like terms because they both have an x to the first power. Then we'd have plus 11x. And then these last two are constants. That means they don't have a variable, so they're never going to change from anything that they are already. So positive 2, negative 5 would end up being minus 3. So this would be our simplified expression. You're going to have the same thing happen here. So the first thing that you have to look for is you have to ask yourself, do the expressions have the same radical on them? So here I'm looking, here's a square root of 6 and here's a square root of 6. So yes, those would be considered like terms. So all you do is go back and combine 2 minus 5. 2 minus 5 is going to be negative 3 square roots of 6. And then this would be your final answer. It's simplified. Unless you were doing an application problem of some sort, you wouldn't go and stick that square root of 6 in a calculator because we don't need to know what the decimal value is. It's somewhere between 2 and 3. It's a decimal value that the square root of 4 would be 2 and the square root of 9 would be a 3. So the value for this would be somewhere between 2 and 3. But it's a decimal value. So here's what we call an exact answer. So when they ask for an exact answer, they want that answer to be left with a radical in it. They don't want you to plug that into a calculator and get it. Okay, so here the question is, do they have the same radicals? Well, the square root of 18 and the square root of 8 are obviously not the same radical. So what we would need to do is the same thing we just got through doing in section 7.2. We need to simplify this radical. So I'm going to call this, break it apart and call it 9 times 2 because I know I can get a square root out of the 9. And the 8 can be broken apart and be 4 times 2, so I know I can get a square root of that. So I'm going to take the square root out of the 9, that's going to give me 3 on the front, square root of 2, and then a minus, and then take the square root out of the 4, that would give me a 2 out in the front and be 2 square roots of 2. Now, yes, your two radicals are the same, so they're both square roots of 2, so you're just going to go back and subtract 3 minus 2 would equal to 1. And it might be helpful to go ahead and put that 1 there just so that you remember, because when you see it just with the square root of 2, it kind of doesn't look right. It's one thing when we have an x without a term and a number in front of it, but it's a different thing when we have a radical. It just kind of looks weird. So make sure that the radicals have the same expression on them. If they don't have the same radical, then you've got to do some work to find out if they will have the same radical. And then if they do, you simply combine the coefficients. So in this next example, I have 1, 2, 3, 4 terms here. So I'm going to try to find ones that match. So here I have a 4 square root of 7, so the identifier is a square root of 7. Over here I got another square root of 7. So the 2 that have square roots of 7 is similar to 2 up here where we have 2 of them that have x squares on them. So I'm going to combine the 2 square roots of 7 by just adding their coefficients. So 4 and a negative 6. So 4 and a negative 6 is going to give me negative 2 square roots of 7. And then I have some that are 5s, and they're different, so they've got to be combined together as a different root. So 8 plus 3 would give me 11 square roots of 5. And then this would be your simplified answer. Just like up here, we have x squares and x's and 3. You can't add those together because they're not like terms. We have the same idea right here. You can't combine them because they don't have the same radical expression. So that's really all we're talking about today. So the first question that you should always ask, this is question number 1. Do the expressions have the same radical? If they do, then you just use their coefficients. So here, I've got square root 2, square root 2, square root 2. So I know my answer is going to have a square root of 2 on it. So then all I'm going to do is go back and say 7 plus 4 is 11 minus 8, that would be 3 square roots of 2. So when we do the second one down, I've got square roots of 5, and this is 1 square root of 5, so it might be helpful to put that 1 there. So 1 square root of 5, and here's minus 3 square roots of 5. 1 minus 3 would be negative 2 square roots of 5. And it's 2 square roots of 6 and a negative 2 square roots of 6. Well, positive 2 and negative 2 would make 0 square roots of 6. But 0 times anything is still going to come out to be 0. So this just comes out to be 0, so your final answer is just negative 2 square roots of 5. Back here, we can see that a positive 2 and a negative 2 would cancel each other out. So basically, those are gone, and you only have to work with the square roots of 5. So you never want to leave an answer that has a 0 times a square root on the front of it. That's 0, so you're not going to write that in. All right, third one down, question, do they have the same radical? Well, no, 75, 27, and 3 are not the same. Now, here's the clue. If you get one of the radicals that is simplified already, and 3 has no numbers that are perfect squares, then the thing you want to do is hopefully this number is going to break apart so that it'll end up with a square root of 3. And this number, we hope, would break apart and also end up with a square root of 3. So I'm going to use my simplify rules. I'm going to find and rewrite 75 as 25 times 3. Then I'm going to take the square root from the 25, and it's going to multiply to the 4 outside here. So the square root of 25 would be 5 times 4. So I get 20 square roots of 3. So now you can see how it's going to start developing. Here, simplified, this would be 9 times 3. So I'm going to get the square root out of the 9. That's going to be a 3, and it's going to multiply out here. So these are the square roots. So plus 6 square root of 3. And then I have minus 5 square root of 3. And now they all have the same radical. You just do the numbers in the front. So 20 plus 6 would be 26 minus 5. So 21 square root of 5. Oh, 3, I'm sorry. Square root of 3. I looked at the one above it. Okay, so on this next one down, notice in the middle we have something that's real simplified out. It's 2 and a W under the radical. So probably these are going to end up with 2 W's. So 72, we have done that on the previous video. You're going to simplify the 72, and it can be 2 times 36, which would be good and easy. And then there's a W back there. So I'm going to take the square root out of the 36, and that'll be 6, and it leaves 2W under the radical. The one here in the middle is going to stay just like it is. And the last one, I'm going to change it and make it 25 times 2 with a W. Take the square root from the 25 out, so that would be minus 5 square root 2W. Now your radicals match, and you simply combine the coefficients together. So 6 minus 3 would be 3, minus 5 would be negative 2. Square root 2W. And that would be your final answer. Now be careful with these when you're doing these homework, because I realize when you're typing in numbers and you got to type in all the symbols and stuff, just be careful. Try not to make silly mistakes. And write the problems down. Do the work on a sheet of paper and then go back and type it in. Alright, this next to the last one here, 6y. 6 does not simplify because it has factors of 2 and 3. It has no perfect squares in it. So that kind of tells you that you want this one to break apart, so it ends up with a 6y. So 54 can be 9 times 6y. Take the square root out of the 9. That's going to give me a 3 to multiply times the 2 that's already outside. So I'm just going to keep that first one, 2 square root 6y. 3 times 2 is going to be minus 6 square root 6y. Now they both have 6 y's on them under the radicals, so the radicals are alike. Just go back and say 2 minus 6. So we get negative 4 square root 6y. Okay, I think you're probably going to catch on to this pretty easily. 27, I can break it apart because these obviously are not like radicals, so I can't add them. So I'm going to break it down and see if I can find something that does match. So I'm going to have 9 times 3. So the square root of the 9 is going to move out, so that'll be a 3 times 8 will be 24 square root of 3. And here I have 125. So how many quarters in $1.25? That'd be 5. So 25 times 5. So this will give me a 5 to come out of the square root and multiply to the front, and that'll be plus 10 square root of 5. And I'm simplified, but one's got a 3 on it and one's got a radical with a 5 underneath it. And so that would just be your final answer, and you can't do anything else with that. So all of these examples will be very similar to some of the problems you have on your homework, and you should be able to finish this assignment and the assignment from 7.2 pretty quickly. So I hope those of you that were not there in class, I will get to see you